All right. Hi, everybody. Thanks for coming. Thanks for the introduction, and thanks for having us here. So today, what I'm going to talk about is a big data solution using JSONiq or JSONiq. There are both ways to pronounce it. And I'm going to start with a little motivation of the problem, why we're doing this. Then most of the talk will actually be a live demo where I try to live develop interesting queries that show you how the language works. And then I will give you some hints for application scenarios, one being the patent use case that was mentioned, and then I will conclude. So today's world is full of data, and you guys all know that. And it comes in a huge variety of data sources. There are relational databases that contain completely structured data. There are more the NoSQL data stores that store a lot of JSON, which is more flexible in its nature, and it can also be hierarchical, nested data. There's XML in XML databases or on the web or used as a data transfer format, where the data can be nested, flexible, schemaless, but also semi-structured, where you can mix and match annotations and text. And then there's pure text that you want to make searchable. Right? For all this information or for all this data to be valuable, people need to do a lot of processing. So they need to aggregate it, they need to clean it, they need to filter it, they need to transform it. There's a lot of stuff that you do in the data mining community to make this data actually valuable. And what we're seeing today is that people are using two kinds of approaches to deal with that. They are either gluing and stitching together solutions around the technology that has been developed in 1978, which is called SQL. Now, as you can imagine, by the time SQL was developed, the data was not as messy as it is today. It was less structured. There was still the idea of a complete mathematical model to process this data. Now, the world has changed, and SQL might not be the right tool for this job. The input to SQL is a table, and the output is a table as well, or a relation. So that doesn't really work for a lot of use cases today. The other movement that we are seeing is that there are a lot of NoSQL, what they call NoSQL data stores. And I'm really saying data store here because those new tools lack a lot of functionality if it comes to querying the data. Most of them provide something that we call baby query languages that allow you mostly to just filter the data and maybe project it. And some of them also allow you to do some aggregation, some analytics on it. But really what we're seeing is that people start to develop solutions or queries in host languages like Python or Ruby. So I was talking to a data scientist who I showed those queries to, and he said, yeah, but that was exactly what I developed last week, and it took me 400 lines of Python code. And then he did the next query on his NoSQL database, and he said, yeah, that took me another week. And then I wanted to give them to a colleague, and the colleague looked at those 400 lines of Python code and said, yeah, but I don't understand it, I'm just doing it myself again, that will be quicker. And so what we see here is that a lot of pressure is put back on the NoSQL developer. And each of them has to reinvent solutions and algorithms and technologies that actually already exist, like an efficient join or an efficient grouping, all these kinds of things that you want to have if you want to query your data. So what I'm going to show you is I'm going to show you a solution, a language that we have been developing. It's called JSONiq. It's an open specification for a new type of language. The language, 28 Milliseconds, the company that I work for, has started the efforts. EMC and Oracle are contributing to it, but it's all under an open source license. And we have also recently seen a little bit of adoption. IBM implemented it in their WebSphere line of products, and there are a couple of open source implementations already available. So what I'm going to do now is I'm going to show you how those queries look like. And I'm going to do this in an in-browser development environment that we have built. In this case, what you see here is connected to a MongoDB database. the MongoDB database contains a subset of the Stack Overflow data as JSON. There are two collections here, and I hope you can read it. This project is not really good. There's the answers collection, and there's the FAQ collection. You can look at one of the answers and how the data is structured in there. So an answer has a question ID, it has an answer ID, creation date, and it also nested has the information of the owner who posted the answer. The owner has a user ID, a display name, a reputation, and other metadata. Okay? Now the increased font size. The FAQ collection is pretty similar. It contains the actual questions. A question has the question ID. It has creation date, last activity date, a score, an answer count, and also the owner information, but also the title and some tags in a JSON array here. And that's the kind of example data set that we will be using for the queries that I'm going to show you. So let me show it to you. The first query that I actually want to do is I want to look through all the questions. So what I'm doing is I'm writing $4Q in collection FAQ, where the questions is answered field is true. I'm going to order it by the question's last edit date. And I'm going to return a new JSON object that contains the title of the question and the last edit date. So now I can execute this, and you get the result. There are a couple of things interesting about this query. So first of all, this construct using the dot navigation allows me to deeply navigate in JSON objects. The other interesting thing here is that using JSONiq, I can construct new JSON objects that contain computed values. So the input is JSON and the output is JSON in this case. Okay. Now, as you see in the result, not all of the questions have the last edited dates available. So it seems like this was a field that was introduced later on, and not all the existing data had that field. So what I want to do is I want to check in the order by clause if there is a last edit date. If yes, I'm going to return it. And if not, I want to put all of those questions at the end. So it will look like this. So now if I run it, you will see that there is a different question on top, and all of the other ones are at the end. Now, the interesting thing about this is that it shows you that JSONiq is a completely composable language. That means wherever a value can occur, you can also have an expression. In this case, I took the if expression and put it in the order by clause. And I can have an expression in every other place here. Does that make sense? So that should give you a feeling of a very high level feeling of one of the simplest queries you can do using JSONiq. I'm happy to take questions as the queries on the screen. Yes, please.
You said that it comes in a way that's can you execute the
Can I?
Can you make these become part of the world?
In general, can you repeat the question?
Can you execute the object?
So I cannot execute the question, but what I can do is I can, in further processing of the query these objects that are temporarily generated. So I could, for example, write another expression at the end that just gives me the title. And in this case, I will just get the titles. So the objects are really constructed within the data model, and the data model here is sequences of items that are being processed in this what is called a flower expression, and you can process them anywhere else. And I'm going to have more examples that I'd like to do this.
I have a question.
Yes, please.
In JSON, you've got arrays as well as dictionaries. If the person expresses his stuff in terms of arrays, particular positional data inside arrays, how do you handle it?
Yes.
Can you repeat the question, please?
So the question was about JSON arrays, that JSON has arrays to model specifically ordered or sorted data. And the answer is yes, there's a concept called an array item, and you can process arrays as well. And I'm going to have examples later on. You will see that. Okay. So let me delete this query, develop the next one. So now I want you to actually look at the answers here. So I'm doing a flower over the answers collection, and I'm going to group all the answers by their owner's display name. And it's owner display name. So again, I can here navigate inside a JSON object. Then what I'm going to do is I'm going to do an aggregation over all the answers in one of the groups. So I'm counting the number of answers per user. I'm ordering it by the count descending, and then again return a new JSON object that in this case contains the user's name, which is unique after the grouping, and the number of answers within each group. So here you can see that the user called Niels van der West posted 16 answers. Okay, so that shows you that JSOniq also has a way to do grouping. JSOniq has a huge function library that allows you to do aggregation and string functions and all this kind of stuff. And in this case particularly, we are using the count function on the set of answers within each group. Okay. Any question? Yes, please.
Actually, it's kind of a comment on the last answer that you gave me. You went on and mentioned, implied that arrays were ordered. In fact, arrays are a primitive type. You can use them as sets, you can use them as orders, you can use them as bags, you can use them as anything. So basically, in order to go on and do this kind of query processing well, it seems to me you'd have to impose semantics externally, which is not being enforced internally. How do you handle that?
It is actually imposed internally. So there's an atomic type, which is called an array, and that can contain any other data type nested. In this case, it will be ordered. And the language has primitives that allow you to extract members of an array. You can either extract all of them or extract one of a specific position.
What if it's not an array? What if I'm using an array to model a set inside my data?
You still have primitives in the language that allow you to unbox the array into a sequence, and then you can use existential or universal quantification on the result.
Never mind. Thank you.
Okay. So
Oh, I see you have the count function. So is there also an ability to do user-defined functions, write something in Python, and you pass data to it?
yes, and I'm going to show you a function in the next example.
Okay.
All right, so now I'm going to slightly modify this query. Instead of the count, I'm computing the average reputation. So I'm using two other functions here, floor and average, that in this case compute the average over the owner's reputation. So here again, answer would be a sequence, and we extract for each of the owners in the sequence the reputation, do an aggregation over it. We will sort by the average reputation and return the name, the average reputation. And also, we are interested in the most highly scored answers, or the questions to the most highly scored answers. So what we're going to do is we're going to, within each group, get all the answers and sort them by their score, descending, and we're going to return the question ID of the answer. And since we're only interested in the top 3 ones here, we're doing a subsequence, and we get only the first to the third. Alright, so now what you can see is that this guy, he doesn't have any reputation fields filled, so you can see that the functions here can also deal with the absence of values. And in this case, the result of this expression is the empty sequence, which then in JSON will be converted to null. And you can see that in the value of JSON object constructor or field constructor, you can have a nested query that computes additional information. The result of this subquery here is a sequence, which will in JSON then be converted to an array. And yeah. Any questions? All right. So now what I'm going to do is I find this pattern here a little bit too long to keep it in this object constructor, and also I would like to factorize it such that other people can use it. So what I'm going to do is I'm going to declare a local function here, which is called top answered questions. It takes as parameters the answers, and in the body I'm literally copy and pasting the expression that was here into the body of this function. And then I'm going to call the function here, top answered questions, and pass it as parameter the answers, and return this one. Okay, so that answers part of your question that you had about the extensibility of the language. The user can in JSONiq declare functions, and again the language is fully composable, so I can just put an arbitrary expression in the body of this function. I can run it, you will get the same result. Now to fully answer your question whether you can also do this in host languages like Python, every function can be declared as external, in which case the implementation needs to provide, the processor needs to provide an implementation for it. So yeah, you can do that in any language you want. It depends on the implementation. So there's an open source processor called Zoba, and it allows you to implement functions in C and C++. And it also has modules that are implemented in Java using JNI. So you can extend the
So you can probably use like JPython to execute. Okay.
Yeah. Some people also develop the C using this the Python C API functions that they call out to Python. If that's something you want to do for efficiency reasons, I'm not sure. But
and what is this? How is this being interpreted? Is there what's the underlying? It's not compilation. It's being interpreted.
No. So this in this case, in this implementation, and that's mostly the open source Zoba processor, the language is compiled.
Okay.
And it's compiled into its own runtime, which is an iterator-based runtime that similar to the one that you would have in a relational database. And this one then is executed on top of the data store, in this case MongoDB. And during the compilation, the implementation is free to use information that the underlying data store provides, like if you have statistics to come up with a better execution plan of the query. Does that make sense? All right. Excuse me?
No, just one.
Okay. So now, as I said in the motivation, what people mostly want to do, and what a lot of the NoSQL data stores provides, is something like a join. So they actually want to join data coming from two different collections. MongoDB, for example, doesn't provide MongoDB's query language doesn't allow you to do that. So what you need to do is, if you really need to join your data, because at the beginning you didn't design your schema like that, and you later on discover that you might need to do a join, then people are doing this in the host language today. So every NoSQL developer starts to invent their own join algorithm, and they decide whether they want to use a hash table, whether they can rely on sorting, or whatever makes a join implementation more efficient. And so from a productivity point of view, I don't think that's an acceptable solution. I understand the NoSQL data stores that they don't want to provide those primitives because it will make their queries slow. But on the other hand, people are still using it, so we should give them a way to do that. One of the quotes that I have heard from one of the NoSQL database vendors is that, yeah, we are fine and we don't want to give people this kind of functionality because they will use it. Yeah, that is true. And then it might be slow in the first place, but then maybe it's your job to make sure that the execution of such a query runs fast.
Just like the gun control lobby. You know,
yeah.
We don't want to give people guns, don't use it.
Exactly. So in JSONiq, you can do that, and it's up to the implementation to determine whether it can execute such a join query efficiently. So what I'm going to do is I'm going to actually do a join here, because as you see that the question IDs are not really useful at the end. So what you really want to do is you want to return a join with the FAQ collection based on the question ID of the question in the FAQ collection, and in this case I'm going to call it ID. Keep the font a little smaller. And I'm going to return the title. Okay, so now I'm doing a join between answers and the FAQ collection based on the question ID field.
Question?
Yes, please.
You mentioned something about it depends on the execution environment to be able to handle this join. Can you explain that? What do you mean?
Yes, so what I mean by this is, and I'm not sure what's going on, so what our implementation in this case, for example, does is because we have a very deep integration with MongoDB, it would look at the MongoDB database and see that there might be a join on question ID. So it would leverage that fact during compilation in order to make sure to leverage that index most efficiently. So you could turn this join into a hash join and make sure you only query the data from Mongo for each of the questions. Right.
So, by the way, the code for Mongo, does it exist in Zorba or no?
The code for Mongo doesn't exist in Zorba.
Yeah, because I just looked, it's not there.
Yes, no, it's
Couch
not.
places, but
Yes, so the integration with Mongo is part of our product, and we're still thinking about making that open source in Zorba. It's a very deep integration, and so that's why we haven't put it open source.
So essentially, you have a query processing engine that's proprietary, but you're saying that others can write their own query processing engine if they want.
Yes. So what we have done at 20 milliseconds is we've taken Zorba and extended it for support to work better on other data stores. One of them being MongoDB, and we've also extended it with another function library. And parts of that is open source, and part of that is not yet open source. So other optimization techniques that we do and that other implementers will have to do if they want to get it efficiently is, in this case, you can tell exactly on which fields are actually used from the data in your MongoDB. So here the display name is used, the reputation is used, the question ID is used, and the title is used. So what you really want to do is you want to make sure that you only retrieve those fields from your Mongo database. So essentially when you send a query to Mongo, you need to tell Mongo to project on the data that is used. So that's something that the processor in this case does automatically, and if you want to get to the same performance, then the developer has to do that as well. Now, one thing that I didn't explain so far, so JSONiq is a completely declarative language, which allows us to do optimization and to highly optimize the execution. One of the optimizations here is that you can tell whether a query is parallelizable, whether you can parallelize the execution across over data sets. So what we do in this case is we could parallelize the execution on several parts of a MongoDB collection in order to get better results. That's kind of like a MapReduce approach, but it's not using, in our implementation, the MapReduce framework. And so that allows you to then scale the execution to the next level. Does that make sense? Okay, so now I want to show you two other things that we can do and that people did with JSONiq and some of the extensions in Zorba. So I said at the beginning that data exists in a variety of sources and formats. So what you actually want to do is you want to maybe join the data coming from a relational database and a MongoDB database. So in this case, what I'm doing is I'm connecting to a JDBC resource, which is a MySQL database on Amazon RDS. And I'm having a query on my MongoDB database, going over the collections, grouping them by question ID, computing the max score, doing some ordering, some filtering after the ordering. And then I'm using the JDBC module that is available here. I'm pushing a query to the MySQL database. And in this case, what I did is I just took the FAQ collection and put it flat into MySQL. And in here, I want to just get all the questions. And then I'm doing a join between the question ID coming from the MySQL database and the ID that is computed in the group from the Mongo data. And I'm returning a result. So what I really did is I took Mongo, I took the relational database, I made a query to the relational database. The results come back and are implicitly transformed into a flat JSON object. And then I can work with it as if it was JSON and do a join between the two of them. Okay, and so that's also a lot of use cases that we see, since people are having more and more data stores. They actually still want to be able to correlate the data between them and get actual results. Does that make sense? Okay, so the next example here is a little bit more complex, and it's going towards one of the application scenarios that I'm going to describe. So every day the Trademark Office publishes all of the updates to the trademark database from the previous day on the web. And they're doing this in an XML file that is zipped up. So in this case, it was from the 1st of June, the updates in a zip file. So that's around, I think each of them has around 250 megabytes after being unzipped. So what we want to do is we want to take this data, process it, transform it, it's XML, we want to transform it into JSON, and then put it in our MongoDB database. So that's what you can do. We have a module that allows you to make HTTP requests. So we make an HTTP request telling us, give me the binary of the zip file. We have an archive module that allows you to extract that zip file. And we're going to get the text out of this, and there's only one file in it. And then we are parsing the XML and using a path expression to retrieve all the case file elements in the dataset. Then for each of them, we're going to extract the mark identification, which is really the name of the trademark. And for each of them, we're constructing a JSON object that contains the serial number, the name, and we also want to make it full text searchable later. So what we're going to do is we full text tokenize the mark identification. And for each of the tokens, we are applying the metaphone algorithm that gives us a string that later we can use to do a phonetic comparison and search for trademarks that sound similar. And then we're also putting the owner information in here. And here's the result out of the 250 megabyte XML. That's one of the trademarks with the metaphone keys, the owner information, and the name. So what we've done is we took a zip file of XML from the web, we parsed it, processed it in a Flower, in JSONiq, and we compute some metadata like full text tokens and metaphone keys, and we transform the XML data into JSON. And now we can go on and do a query on this JSON, or just put it in our MongoDB database to make it later on searchable by some web interface. Does that make sense? So this shows you that JSONiq can not only process JSON data, but also XML data. And in fact, some of you might notice that the language might look similar to a language that has been around for quite some time, which is called XQuery. XQuery is a language by the W3C. And what JSONiq really is, it is an extension of XQuery to be able to process JSON data. It also removes some of the functionality in order to get a nicer syntax for JSON users, but the language really is a strict superset of XQuery. And that allows you to actually process XML and JSON in the same query. Make sense? So there are two application scenarios that I would like to briefly describe to you, one of which we already have seen a little bit in action. So the Trademark Office publishes all of its data as XML on the web. There's 1 terabyte that's ended up since 1850, around 1 terabyte of XML data. And the law firm came to us and said, we've been trying to develop an application using, I think it was PHP and WordPress and the MySQL database to make this data searchable. And not only we want to make it searchable, but we also want to transform it into some nice web page. And we also want to use it in our office to see, to get the latest updates from the Trademark Office and see if a trademark expires, and those guys might take action if they are responsible for it in order to make the customer a new office to extend the trademark. And they said, we've been developing this we've outsourced this, and we've been developing it for 4 months. And the application was never really running. They said they imported around 10% of the data, and they never knew whether the application was still running or crashing, and they didn't really trust in it. And so they said, can you do this for us? We said, yeah, that looks like a nice use case. So it took us around 1.5 weeks with one developer to develop the entire solution and integrate the entire data set. So what is there is now, there's a MongoDB database that contains around 7 to 8 million trademarks, the metadata for them. There are 8 million HTML pages out of each of the trademark pages that are generated and put on S3, such that people can crawl them, and they're they're Google indexable. And also there's an application in the backend that allows the lawyers to see which trademarks they are responsible for, to sort them, to look at the expiration date, all this kind of stuff. And it's really only around 300 lines of code, modulo the HTML, that was needed in JSONiq to develop this kind of application. And yeah, they are really happy, and it works really well for them. So that's one of the use cases that you see. And yeah, as I said, they try to, before, take this data, shred it into MySQL, have some PHP WordPress solution on it, but I'm sure you can make it work, but for them it didn't really work.
Why static pages? Why so many static pages? Why can't?
Oh.
Can you repeat the questions?
So the question was, why generating so many static pages? So on the client's website, if you search for a trademark and you found one, you want to look at all the metadata around the trademark. And you could either generate it dynamically, but we decided to cache them simply, and mostly because it will otherwise crawlers will put a lot of pressure on the infrastructure, and this guy didn't buy a package that allows him to do as many queries. If you have 8 million trademarks and the number of queries in his project is limited, and the crawler will probably within the first 3 months eat up all this quota. So that's why we decided to put them static.
It is not any limitation with JSONiq.
No. The pages are generated in JSONiq, and whether you put it on S3 or you serve it on demand, you can do both of that. Yes.
Can you repeat please how many lines it's application?
So I can't give you the exact number, but I know it's around 300. 300, yes.
Impressive.
And even a lawyer can start to maintain it now.
A patent lawyer.
A patent lawyer.
They're a little more technical.
Okay. He's really
I
technical.
just wonder if the data is in database or in MongoDB or just a flat file system.
Oh, so originally the data is just on Google storage. And then what we do is we take each of the files and extract the metadata that we need to make it searchable.
So their file is a file system.
And this we
in relation database.
and so the metadata we extract we put in Mongo.
Is the USPTO's data stored inside a relation database or just a flat file?
Oh, I don't know how the USPTO internally stores its data, but they make the data available as a zip file on the web. It's a plain file.
Be a file system.
Yeah, it's, I don't know, whatever Google storage gives them.
It was a zipped XML file?
Yes.
Okay.
It's using a zipped XML. So the other big application scenario that we are currently working with is XBRL. Some of you might have heard about it. XBRL is an exchange format for financial information. And it's going to be mandated next year so that entities have to, using XBRL, file to the SEC. So the SEC is going to mandate that. Now, it's XML. All of the data is XML. And it's really being optimized for transfer and extensibility. The problem with this is that it makes it very hard to query. So if you want to query this kind of complex information, there's really no way to do it. Each company has taxonomy extensions to the US GAAP that they use and file with the SEC. XBRL is going to be mandated all over the world. Europe is mandating it, Australia. So that is really seeing a lot of movement. And now people are getting nervous because two things. The filers have really no way to generate this kind of the XBRL filings. So what we see them doing is they're manually editing XML files in Word. And next year, starting next year, they're going to be liable for that information. And as you can imagine, if you manually edit an XML file, there might be mistakes that sneak in. So those guys are getting nervous. And on the other side, the analysts are nervous because they really have no way to do analysis on all of the SEC filings. So what we said is, that looks like a great use case to us. So what we did is we build a prototype that is called that is available on XBRL.io, xbrl.io. It's in private beta. What it does is it takes all of the XBRL filings that are out there, either by the SEC or by any private company. You can put the information in there. We extract information out of those XBRL filings and compute something that we call an info set, a semantic info set, that gives all of the information that a business user needs. We started in JSON just because some people find it easier to process, and we started in MongoDB. We have an extension modules using functions that give the business user a common functionality that they need to do, like give me the last filing date, or give me the value for a specific fact, or give me the entities that are in a specific category with the SEC. And so suddenly the analysts with 5 lines of code can do really complex analysis over all the SEC filings that are out there. And
question? Do you have any slides to go with that, like examples or anything?
No, I don't. But I can provide you offline with information if you want about this. So, and I wouldn't say the XBRL data is really big data because it's all human generated, human written. So how big can it get? But it's really complex data. And right now, they're really lacking technologies. They're all using SQL and shred the XBRL files into a SQL database, and then business users try to join in their head together the information like it was shredded, and they're having big problems with that. And so we've showed them JSONiq queries using these module extensions that we call BizQL, the business query language. And they love it, and they can do it. And each of them can write a simple query that does the analysis for the stuff that they need to do.
They never attempted to do Sparkle and triple stores, which would seem to be another approach to
yes, that's indeed another approach. But so we're working together with consultants in this space, and they seem to have trouble with the solution. But what you could do is you could actually translate Sparkle into JSONiq and then run it on top of the data as well. So to conclude, what I did is I showed you a powerful and productive query language for NoSQL. I've shown you most of the examples that I've shown you are running on top of MongoDB, but I've also showed you examples that join federated data sources in different formats. We've seen getting data from the web, getting data from a relational database, getting data in XML. I've explained you or showed you 2 of the application scenarios that 20th millisecond my company is currently focusing on. And the reference of JSONiq is available on JSONiq.org. It's an open specification. And our product and the sandbox that you saw that you can use to execute example queries is available on 28.io. We also had a book at the entrance, and for those guys who weren't able to get a copy of the book, there's a link to a sign-up page or to a page where you can actually download the book electronically or for a Kindle. So in case you want to have that, that's available there for free. That's it. Thank you very much. Happy to take more questions either online or offline. I think we will still be around. Please.
Do you have any comments about language with the recipe, how to do a query, with more examples, just simple?
Yes, so this book.
Can you repeat the question?
Yeah, so the question was whether there are more complete examples that show you how you can use it and integrate it in your language of choice, the queries, because the book really is only syntax. So yeah, the book is meant to be an easy introduction into the language. We didn't really want to make it for any of the particular products. But you can take each of the examples and literally copy and paste them into 28.io. 28.io you can create a free account, and you can just put the queries in there, and each of the queries is exposed using a REST API, and you can find more documentation on there how you can use that REST API and then invoke the queries from the language of your choice. Yes, please.
What's kind of the edges of the language?
The edges of the language?
Yeah.
So that's a good question. So I think you can extend it with a lot of functionality. If you want to put any data mining algorithms in there, you can put them in there. There are also extensions to do updates. So you can update either collections or JSON objects or JSON arrays. There's a full text extension as well for it that allows you to do full text queries. So it covers really a broad spectrum. And the edges are really up to the implementation in terms of performance and which use cases it supports best. It's a powerful language, and each implementation might have strengths and weaknesses.
So that's kind of my fault. It's like, where's the speed bottleneck? Like, where do you see the speed bottlenecks?
The speed bottleneck?
Yeah.
So in this approach where you saw federated data sources, where you query MongoDB and something else, the bottleneck is obviously how fast can you get the data out of those stores. And the rule from Jim Cray obviously holds, which is if you want to have fast queries, you need to bring the queries to the data. So if you really want to get the best performance, you need to do the implementation of JSONiq within the data store. If you have, on the other hand, if you separate the query processing from the data store, you can achieve you have other advantages because you can scale them independently, and especially if you do parallelization and only do queries to MongoDB that could be answered in constant memory, then that might be an advantage as well. So the problem is really how do you get to the data, and what's the physical representation of the data model that you operate on.
In one of your early slides, you had different data sources like relational, JSON, XML, and text. Is there much specific to text processing that JSONiq can do that other systems can't do as easily?
So,
I mean, as far as like search or...
Other systems can do it as well. And clearly, Lucene with a Solar or Elasticsearch are great tools and scalable tools that allow you to do full text. But the syntax is still kind of hard to get. So I can give you an example of a full text query in JSONiq. Not sure what's going on. So you can have a query loop. Just quit the browser again and start it. So there's a complete full text extension that allows you to do all kinds of queries. I got locked out. So here is Luke. I am your father, and you can ask it contains text, Dad. Now, obviously, the answer will be false, but you can say using thesaurus default, in which case hopefully this will return true. So there's a huge full text extension that you can use to make it easier for the user to do the queries. In terms of the functionality that you want to have, it really depends on whether you have good full text indexes and all this kind of stuff. Does that make sense?
So if you made your own thesaurus, say out of like, SKUs, product names, that all map to the same product.
Yes.
Then you could use that as a way of mapping things together.
Exactly. You can. This is just the default thesaurus here, which is a WordNet thesaurus, but you can plug any other thesaurus in there and then do comparison according to the thesaurus that you have. And there is a way to do full text stemming, tokenization in all different languages. You have within distance of multiple words, you have functionality in same sentence, all this kind of stuff. So the language is really, really powerful there.
And is that part of the JSONiq language itself, or what you plug into it as far as WordNet and things?
So the specification here again also comes from Xquery full text.
Okay.
And we didn't put it yet into the JSONiq specification because we want to keep the core JSONiq specification small in order to allow implementers to implement the language and don't see the big...
Not to be too intimidated.
Yes.
By extra stuff. Okay.
Yes. Yes, please.
Do you have a connection into the graph databases like the Neo and HyperDB and Infinity?
No, we don't. So the question is whether we have a connection to any of the graph databases. So Neo4j has a query language called Cypher. It's declarative. It has a very nice syntax that allows you to navigate into graphs. So you can navigate edges and multiple edges. I think it's a great language for graphs. We could extend JSONiq to put the graph navigation part of Cypher into the language itself, into JSONiq language. That would be a possible extension. We could do that. But at the moment, I think it makes sense to develop those languages separately. We've been talking to the Neo4j guys. It's a completely different community, and everybody wants to evolve their language. Yes, please.
It sounds like this is part of your implementation is adding joins to MongoDB. What's your experience with that? What has your experience been with that? I mean, they didn't want to do it. You got it on top. How bad is it?
So the question is, what's our experience with adding join functionality to MongoDB? So we are talking to a lot of MongoDB people. And there are two types of people there. There are guys who are doing their startup, who want to rapidly prototype something, and they are perfectly fine with developing a Python program that does the join. And they want to do it themselves, and they don't want to hear about a high-level declarative language. And that's a huge part of the MongoDB community. But then also, I gave you the example at the beginning where people in enterprises are trying to adopt Mongo for use cases where they need to do analytics on it and do more stuff that goes beyond the Mongo query language. And there, those guys are really, really interested and are using this functionality.
I can believe that. My question, I guess, is more along the line of performance. That is, you've gone over, basically putting stuff in there that wasn't designed to support it at the beginning. What's the performance implications of that inside of the language?
Yeah. So I can give you an example of a benchmark that we recently did. So there's the University of Berkeley published a big data benchmark, and they benchmarked several systems, one of them being Hive, which is the MapReduce Hadoop implementation. So what we did is we took the same data set, put it in Mongo. MongoDB has clearly limits regarding the size compared to any other data store. So we filled it up as much as our MongoDB installations can handle, which is comparable to their data set. And we executed the same queries from this benchmark, translated them into JSONiq, and executed them in parallel. And we are in the same order of magnitude than the Hive implementation.
Okay. Thank you.
So the question is, how does the parallelization work in this case? So again, it's up to the implementation. The open source implementation doesn't have any way to parallelize the queries. We did that in our product, and so there are two layers essentially. First of all, there are functions that allow you to manually parallelize the execution, which means you can chunk the input, you can shuffle, and you can then do the reduce part and split the execution over multiple processes. And then there is an extension to the optimizer, that tries to detect patterns that it can automatically parallelize. And then in these cases, the optimizer will put those primitives, those functions that otherwise the user would have to do automatically.
But language itself, free from any pragmas like parallel or something.
So there are also, so the language provides extension points which are called pragmas, and there are pragmas like in any other SQL implementation that allow you to turn on and off or give optimizer hints. So you could turn parallelization off, or you can turn other optimization features off or on within the language. Yes, please.
Now, how does it compare to the SQL Hadoop sort of projects?
So the question is, how does it compare to the SQL Hadoop kind of projects? That's a very good question. So there's a lot of traction with several Hadoop and big data vendors that started to put SQL on Hadoop. I think the most prominent one there is Impala from Cloudera. And what they are trying to do, I think, is they try to fit a technology that is not really designed for the kind of data that they have in their Hadoop clusters to query the data. So if they use SQL, it still mostly requires the data to be structured and in a table kind of form. They have functions that allow them to do a little bit parsing JSON and querying JSON. But I think in the long run, you will need a much more powerful language to deal with the complex data formats that you have in Hadoop clusters. So I think that's my personal opinion. SQL is not the right choice for this. But on the other hand, I completely understand their arguments that what people know and developers know is SQL. And if you want to talk to those people and give them a quick way to work with what they know, then SQL is the right choice. Also, SQL is the right choice because a lot of products, BI tools, understand SQL. And so using SQL, it opens them the entire market to those tools. But personally, I don't think it's the right language for this kind of data. Yes, please.
Right now in the market, new languages coming, Scala.
Sorry? Scalar?
Yeah, and I think they are also trying to use implementing with SQL and MongoDB. How is that?
Yes. So the question is how other SQL implementations of MongoDB in the Scalar environment, how it compares to that.
Yeah.
So it has the same problems. I've seen several SQL implementations on top of MongoDB. All have to deal with different things. So the arrays were mentioned at the beginning. So I've seen an implementation that takes an array and normalizes the data in an array. And then in the SQL query, you have to manually join the data, knowing that it was an array previously in the data. So I think that is a very error-prone.
Well, thank you very much. There's other questions, I'm sure the speaker.
One announcement.
Oh, did you want to make an announcement?